Right, lads, this is a solids in contact question, page 57, question 3. Now you're given these two shapes in the start of the question: a cone, height 90, diameter 80, and a sphere of radius 36 that's in contact with it. The question is outlined here like this. So you see the positioning of the sphere in line with the side of the cone, and the measurements are given there in the question. The elevation itself is very straightforward to draw. Start off drawing your cone, no difficulty there, you're given all the measurements. You can also draw in your sphere, again with no difficulty. You just line it up with the side. It's radius 36, so step up 36 and draw it in. So the elevation is very easy to have in its final position. You drop down to the plan view then. You could start by replicating the cone down in plan view, so it's going to look like a large circle. So that's the plan of the cone. And then the plan of the sphere is going to cause a little bit of difficulty for people. We'll take the centre point of it, we drop it straight down, but we don't know where to stop it. They don't give us a measurement for that. So what I did in this case was I took the sphere and I rolled it out to the side of the cone. So you'll see this secondary one here up in elevation. So that's exactly the same size of a sphere, but just rolled out so it's in contact with the side of the cone. Now I did that by stepping up 36 from the ground and stepping out 36 from the side of the cone. That gave you the centre point of this temporary sphere. So it's in contact with the side of the cone. I dropped that down so that it's in line with the side of the cone in plan view, and then all you're doing is rotating it around into its position. So you're taking that temporary sphere, which is on the side of the cone, you're dropping it down. When you get to the halfway point, the centre line, you're taking that centre point and you're swinging it around, and you're swinging it around until it's in contact with the original centre line coming down, and that will give you the position of the proper sphere in plan view. Okay, again, I'll spend more time on that when we're just finished this, if people are still confused. So that completes your plan view and your elevation of your cone and your sphere A. Now, part 2 of the question, lads, is asking you to draw the projections of a second sphere with a diameter of 30, which touches both solids, and it tells you that it makes contact with the original sphere at a point which is 44 millimeters above the horizontal plane. Okay, so I'm just going to list off the different things that they're telling us to pay attention to there. First of all, we're drawing a sphere. It has to be in contact with both solids. The point of contact, the POC, has to be 44 millimeters above the horizontal plane with the original sphere A. Okay, they don't tell us where the point of contact has to be with the cone, but they tell us that it has to be in contact with that large sphere we drew at the beginning, 44 millimeters above the ground. Now it doesn't say that the actual sphere we're going to be drawing also has to be touching the ground. It doesn't say that, so that's a clue in itself. So the best thing to do would be to go to the ground line and measure up 44. I'm just going to draw a straight line going across. So I know that whatever sphere I'm going to draw, the point of contact has to be somewhere along that line for the sphere. For the two spheres together, the point of contact has to be somewhere along that line. Now when you have two spheres drawn together, if they were side by side, to find the point of contact you would simply join the two centres together. So I'm going to bear that in mind. What I'm going to do is I'm going to take my centre point of the sphere that I have, and I'm going to join it through where the 44 line cuts the side of it. Okay, I'm going to continue the line out, and I'm going to draw a circle or a sphere that is diameter 30, so radius 15, as it outlines in the question. So I'm going to add 15 onto that line. That'll give me my centre point. Draw in that temporary sphere, so that's the right size. It's in contact with the large sphere at a point which is 44 millimeters above the ground, but it's not in contact with the cone, so we haven't completed the whole thing. It has to be touching the two of them at the same time. So I've completed half of the criteria. Now I'm going to go over to the other side of the elevation, and I'm going to just concentrate on that sphere touching the cone. I'm not going to worry about the large sphere, but I'm going to keep it at the same height that it is over here. So we'll take the height that we have on the left, transfer it over to the right hand side, and now we're going to draw a radius 15 sphere that has a center point somewhere along here, and it's in contact with the side of this cone. Okay, so if it's going to be radius 15 and it's going to be in contact with the side of the cone, I'm going to measure out 15 from the edge and draw a parallel line. It'll cross over that center point that I brought over. And again, I draw a temporary sphere that's in contact with the side of the cone and is again a certain distance off the ground. So the two of them are doing completely different things at the same time. And now what I have to do is try and combine them. Try and have them doing both things at the same time. So what we're going to do is, if you can imagine one of those, imagine those just as footballs. We're going to take that football and we're going to spin it around the cone. And we're going to take this football here and we're going to spin it around the larger circle. And what happens is we're going to look for where they intersect. Where are they doing both things at the same time? So I'll start off with the cone one. My radius 15 sphere. I'm going to drop it down to the plan view. It's at the side of the cone here, so that's where I'll pick it up. And I'm going to spin it around. Okay, so anywhere along that arc that I've just drawn, I could draw a radius 15 sphere and it would be in contact with the cone. Would you agree with that? Now I'm going to do exactly the same thing with these other two shapes. I'm going to take my radius 15 sphere, drop it down. In this current view, it's at the side of the sphere, so again, that's where I'll pick it up in the plan view, and I'll spin it around. And likewise, anywhere along that arc, I could draw a radius 15 sphere and it would be in contact with the large sphere here. So what we're looking for is, where is it doing both of those things at the same time? And that's at the intersection point. So where those two arcs that I've drawn cross over each other, it's completing both of those things at the same time. Make sure you keep the same radius. Pick up that new center point and draw in the plan view of your new sphere. Okay, and you'll see it's slightly overlapping both shapes, as it would in real life. That's the final position of it in plan view. So all we have to do is bring that up to the elevation. We know the height of it because those two are level to start off with, so it's not going to change. We've brought the new center point up. That's where they cross over. Keep the same radius. Make sure that doesn't change on you. Okay, and that would be the final position of it in the elevation. So then you just have to decide, well, what's in front of what, and what do I draw heavy and what do I draw as a broken line. So I'm just going to quickly sketch it in just so you can kind of make it out. So the way I'm reading it, you're looking up in your elevation in that direction. Okay, you're looking upwards. So this large sphere is going to overshadow the small part of that smaller one, and most of this third shape that we drew is going to be overshadowing the cone because it's in front of it. So we'll draw it that way. Draw the large sphere in its entirety. I'm just sketching this heavy quickly just so it's on the video, but do this neatly. Use your compass for drawing any circles. The large one, the smaller one slightly behind it. Broken lines where you have hidden detail, and then the cone behind all two of them. And again, broken detail where you have it. Then look down on your plan view. Again, the large sphere itself is going to overshadow everything. Small part of this smaller sphere will be hidden detail, the rest will be all visible. and then a good portion of the cone is going to be hidden wherever it overlaps the other two shapes. So that'll be hidden detail there. Okay, that's that question done.